My name is David Arnold, and for this project, I analyzed Spotify track data using machine learning techniques. The goal of my project was to explore factors related to track popularity and determine how clustering and classification models could be used to generate business insights within the music streaming industry. So, moving on to business problem and project overview. So, music streaming platforms such as Spotify generate enormous amounts of data related to artists, tracks, and listener behaviors. So, understanding these factors that contribute to popularity can help streaming services improve recommendations, support marketing decisions, and better engage users. So, the objective of this project was to apply clustering and classification techniques to Spotify track data in order to identify meaningful patterns among artists and tracks, and also predict whether a song would likely be considered popular or non popular. So, going over the methods I used, this project followed a structured machine learning workflow. I began with data cleaning and feature engineering to prepare the data set for the analysis. Next step, I applied k-means clustering to identify natural groupings within the Spotify data. Um, then I developed a random forest classification model to predict track popularity outcomes. And then lastly, I evaluated model performance and interpreted the results from both a business and ethical perspective. K-means was selected because it's effective for segmentation, while random forest was chosen because it performs well on structured data sets and also provides very useful feature importance metrics. So some of the key data insights after reviewing and exploring the data. During my exploratory analysis, several important patterns emerged. So artist popularity and follower counts appeared to have strong relationships with overall track popularity. Also, track duration and the engineered artist influence score, they also appeared to contribute to streaming success. Before modeling, several pre-processing steps were required. So these steps included selecting relevant variables, engineering the artist's influence score, and converting categorical variables into numerical values. Also standardizing features for clustering and creating a binary popularity variable for classification. The cluster distribution shown here demonstrates that the dataset contains multiple artist and track segments of varying sizes. Moving on to the overview of the models. So two machine learning approaches were used in this project. First one, the k-means clustering. It was used to identify natural groupings among artists and tracks. This approach helps uncover hidden patterns and can support audience segmentation and recommendation strategies. Second, the random forest classification was used to predict whether a track would likely be categorized as popular or not popular, or excuse me, non-popular. This model provides predictive insights that can support marketing and promotional business decision making. Together, these two models can provide both exploratory and predictive perspectives on the Spotify dataset. Model evaluation and performance, technical side. To evaluate the random forest model, several performance metrics were calculated. The model achieved approximately 76% accuracy with precision recall and F1 scores of approximately 0.58. The confusion matrix shows that the model correctly classified a large number of tracks, while the ROC curve demonstrates its ability to distinguish between popular and non-popular tracks across multiple thresholds. So overall, the model demonstrated reasonable predictive performance, given the extreme complexity of music popularity in this data set. From a business perspective, the model was reasonably effective at identifying tracks with higher popularity potential. The feature importance analysis revealed that track duration, Artist influence score, artist follower count, and cluster assignment were among the strongest predictors of popularity. These findings suggest that audience reach and artist visibility really play important roles in streaming success. At the same time, the model still produced some misclassifications, which reminds us that music popularity is influenced by many subjective and unpredictable factors beyond the variables included in this particular data set. These insights could potentially support recommendation systems, placement strategies within different playlists on the platform, and also promotional and marketing decision making. Moving on to some recommendations. So based on the results of this analysis, I would say several recommendations can be made. The first is that clustering results could be used to improve artist segmentation by identifying mainstream, emerging, and even niche artist groups. Secondly, recommendation systems could incorporate clustering insights to improve content discovery while also increasing visibility for newer and emerging artists. Finally, organizations should continue monitoring factors such as artist influence, follower growth, and audience engagement when evaluating these tracks' performance. Future improvements to this project could include incorporating additional Spotify audio features, testing other machine learning models, and also expanding feature engineering efforts. Moving on to ethical considerations. So one important ethical consideration in this project involves popularity bias. Because the variables such as artist popularity and follower counts were included in the dataset, the models may naturally favor already popular and established artists. This could unfortunately unintentionally reinforce existing advantages while limiting exposure for newer, less established artists. To address this concern, I emphasize transparency through the analysis and acknowledge model limitations rather than treating the results as objective measures of musical quality. The findings were communicated to both technical and non-technical audiences, and the results were interpreted as indicators of engagement and visibility rather than definitive measures of artistic value. Some key takeaways of the analysis. In summary, the clustering analysis successfully identified meaningful artists and track segments within the Spotify dataset. The random forest model achieved approximately 76% accuracy when predicting track popularity outcomes, with artist influence, follower counts, and track duration emerging as some of the most important predictors. Overall, the project demonstrated how these machine learning techniques can support recommendation systems, audience targeting, and promotional business decisions, while also highlighting the importance of ethical interpretation and the responsible communication of these results. I just want to say thank you for your time, and I welcome any questions.